The future of the car industry has never been quiet. It has never been calm, and it has never been neutral. Every generation believes it is witnessing change. But sometimes change isn't evolution. It's a power shift. And right now, that shift is happening in the silent beams of LiDAR sensors scanning the roads of Beijing, Detroit, Silicon Valley, because the next automotive war isn't about horsepower. It isn't about fuel economy. It isn't even about electric range. It's about who sees first and who stops first. Welcome to the LiDAR Wars. To understand why this matters, we have to go back. Long before electric SUVs, long before AI chips, back to a time when autonomous driving was a dream inside university laboratories. In 2004, the DARPA Grand Challenge shocked the world. Vehicles attempted to drive themselves across desert terrain. Most failed, some barely moved, but something ignited. Engineers realized that cameras alone weren't enough. Radar wasn't enough. They needed depth. They needed precision. They needed a way for cars to see in 3 dimensions. That's where LiDAR entered the conversation. Light detection and ranging, a technology that fires millions of laser pulses per second, measuring distance with microscopic precision. Suddenly, vehicles could map the world in 3D. Not guess, not approximate, measure. For years, LiDAR was bulky, expensive, experimental. It sat on test vehicles like spinning towers. It screamed prototype. But innovation has a rhythm. It shrinks. It refines. It becomes invisible. And that's exactly what happened. Fast forward to today. Chinese smart SUVs are rolling out with roof-mounted LiDAR as a standard feature. The new GWM Tank 500 2026 SUV arrives with LiDAR on the roof. 27 sensors surrounding the vehicle, military-inspired detection systems capable of spotting vehicles at 120 meters, pedestrians at 90 meters. This isn't concept car fantasy. It's production reality. And while China is integrating LiDAR into mainstream SUVs, America is recalibrating its strategy. Luminar Technologies wants to light up China's smart vehicles. Think about that for a second. An American LiDAR company supplying sensors to Chinese EV platforms. Because innovation doesn't respect borders. It follows ambition. But ambition is accelerating on both sides. Chinese automakers like Leapmotor revealed the A10 compact SUV with 500 kilometers range. LiDAR integration, regulatory filings confirming advanced sensor stacks. This isn't niche anymore. It's scale. And scale changes everything. Meanwhile, in America, Rivian is building what it calls a new brain. RAP1, Gen 3 autonomy computer, a dedicated AI system designed to process sensor data faster than ever before. They revealed a new AI chip. They're adding rooftop LiDAR to the upcoming R2 EVs. And they understand something critical. Hardware without intelligence is useless. LiDAR alone doesn't make a vehicle autonomous. Processing power does. This is where the emotional tension begins. Because for decades, automotive dominance rotated predictably. America led manufacturing scale. Germany perfected mechanical precision. Japan mastered reliability. But in the EV and autonomy era, China moved aggressively. They didn't just electrify vehicles. They digitized them. Vertical integration, battery dominance, semiconductor partnerships. And now, LiDAR at scale. But here's the twist. The LiDAR story isn't just about hardware. It's about trust. Consumers must believe that their vehicle sees better than they do. That when a child runs across a road at night, the SUV reacts faster than human reflex. That when rain blurs vision, the system still maps obstacles accurately. Testing standards have evolved because of this. Automotive LiDAR performance test methods in dynamic driving conditions now measure detection accuracy, false positive rates, latency under motion, object classification reliability. This is no longer lab testing. This is real-world chaos simulation, and it's necessary because autonomous driving history is filled with hype cycles, promises made too early, timelines that slipped, and public trust shaken by isolated failures. That's why the integration of LiDAR into mainstream SUVs in 2026 feels different. It isn't being sold as full autonomy. It's being positioned as advanced braking support, LiDAR-Powered Braking. And that subtle framing is powerful. Instead of promising hands-free highways, manufacturers promise something simpler, safer stopping, earlier detection, reduced collisions, and safety cells. SUV buyers are families, parents, commuters, people who care less about lap times and more about protection. Now imagine this scenario. You're driving at dusk, visibility dropping. A cyclist appears from behind a parked van. Human reaction time averages around 1.5 seconds. At 60 km/h, that's over 25 meters traveled before braking even begins. LiDAR detection systems scanning at high frequency can identify obstacles almost instantly, milliseconds. That difference can mean everything. This is where the emotional weight sits. Because when we talk about LiDAR wars, we're really talking about prevention, about reducing tragedy, about rewriting accident statistics. And yet, it's still competition. Because whoever perfects perception technology first owns the narrative. China's push into LiDAR integration reflects strategic boldness. Companies are deploying rooftop modules despite aesthetic criticism, despite cost increases, because they believe perception superiority will become a selling point. Meanwhile, American manufacturers evaluate carefully, balancing cost, brand positioning, long-term reliability. Rivian's approach with its Gen 3 autonomy computer suggests something deeper. They're not just adding sensors. They're redesigning architecture, centralized compute platforms, AI acceleration, over-the-air updates refining detection models. That's the second layer of this war. Software supremacy. LiDAR generates enormous data, millions of points per second. Raw data is useless without interpretation. Machine learning models must classify pedestrian, vehicle, static object, debris, shadow, reflection. Every misclassification is a risk, and this is where historical perspective matters again. In the early 1900s, cars competed on horsepower. In the 1950s, they competed on chrome and style. In the 1980s, on fuel efficiency. In the 2000s, on infotainment. But in the 2020s and beyond, they compete on intelligence, on perception, on how well they understand the world. And this intelligence war is subtle. Consumers don't always see it. They see sleek SUVs, panoramic roofs, digital dashboards. But under that surface, lasers are firing, chips are calculating, algorithms are predicting trajectories. This is the invisible revolution. And revolutions rarely announce themselves loudly. They integrate quietly, then suddenly feel inevitable. There's also geopolitical undertone here. U.S. LiDAR makers eye Chinese markets because China builds EVs at scale. China integrates LiDAR rapidly because scale reduces cost. Cost reduction makes LiDAR mainstream. Mainstream adoption pressures competitors globally. It's a feedback loop. And the global SUV market becomes the battlefield. But let's pause emotionally for a moment, because beyond competition and algorithms, there's something human here. For over a century, driving symbolized control, hands on the wheel, feet on pedals, eyes scanning the road. LiDAR shifts part of that responsibility to machines. It asks drivers to trust, to share control. That psychological transition is profound, and adoption curves reflect that tension. Some resist, some embrace. Most hover somewhere in between. But progress rarely waits for consensus. It advances, and the companies that commit early often shape standards. If 2026 becomes a year LiDAR-powered braking proves statistically superior, regulators may respond, insurance models may change, safety ratings may evolve, and suddenly, LiDAR isn't optional. It's expected. Think about airbags. Once revolutionary, now mandatory. ABS, once luxury, now baseline. LiDAR could follow that path. And if that happens, the 2026 SUV generation will be remembered as a turning point. So where does this leave us? In the middle of an industry rewrite. Chinese SUVs arriving with 27 sensors and military-inspired detection systems. American EV startups building AI brains capable of processing LiDAR streams in real time. Global suppliers racing to reduce costs and improve resolution. Testing protocols expanding to measure dynamic reliability. And consumers slowly realizing their vehicles are becoming perceptive machines. The LiDAR war isn't loud. It doesn't roar like engines. It hums quietly in computation. But it might be the most important automotive shift of our era. Because seeing better means reacting sooner. And reacting sooner means saving lives. And when technology intersects with human safety, innovation stops being optional. It becomes inevitable. So the question isn't whether LiDAR will shape the smartest SUVs of 2026. The question is, who will lead that vision? China, America, or the company bold enough to fuse hardware brilliance with software mastery? Because in this new chapter of automotive history, victory won't belong to the fastest car. It will belong to the car that sees first, understands first, and stops first. And that is the future quietly arriving on the roofs of SUVs in 2026.